So when we have a problem that's written this way, we want to take a look at, we call these the coefficients. They're just the numbers that are in front of our variables. I'm going to highlight them. Now, I'm going to highlight these two numbers with yellow, these two coefficients, and I'm going to highlight these other two with a different color, with pink. So we could use either the yellow numbers or the pink numbers. We just want to use the ones that are the easiest, the smallest, and the ones that have the easiest common multiple also. So I'm going to use the yellow ones. And when I say the easiest, it's usually the ones, I don't want to say always, but usually the ones that are smaller. So that's kind of what we have here. But first, let's make sure we understand what the common multiples are. So I'm going to write this with my text tool. We need to find the common multiple actually the lowest common multiple or least common multiple. Spell that right? Of 2 and 3. It's sometimes called the LCD, but or sometimes it's just called the multiple. So to do that, what I'm going to do is I'm going to write down the multiples of both of these. Let me make that a little bit larger. I'm going to write down the multiples of 2 and of 3, see if I can get this to work. There we go. All right, so the multiples of 2. Well, when I say the multiples, I mean 2 times 1 and 2 times 2 and 2 times 3 and so on and so forth. Well, 2 times 1 is 2. 2 times 2 is 4. I'm sorry. Yeah, 2 times 2 is 4. 2 times 3. 2 times 3 is 6. And you just count by 2s also. 2 times 4 is 8. And we could just keep going, but I'm going to stop there. The multiples of 3, again, what we're going to do is just 3 times 1 and 3 times 2 and so on. So we start with 3. 3 times 2 is 6. 3 times 3 is 9. We could go to 12. We could go all day, but I'm going to stop here because what I want you to notice is that these two numbers have some multiple in common, and that they have others in common, but we want to use the easiest one, and that is a 6. They both have a 6 in their list of multiples. I'm trying to highlight that there. Why won't it stay? I don't know. Okay. They both have a 6. Blow it up a little bit, maybe. Okay. So we want to use a positive 6 and a negative 6 in our equations. Let me write that down here. Since our lowest common multiple, let me just use that letter here, LCD, is 6. We're going to want to use a 6 and a negative 6 in our equivalent equations. Okay. So that's why we do it and what we need, but now let me show you how we're going to use this. As always, we want to go ahead and write the equations down, even though they did. So I'm going to write again the 2x and positive 3y and 17. The other equation is 3x plus 4y is equal to 24. Now, one more time, let me remind you, these two numbers, we're going to want those to be a positive 6 and a negative 6. So to get that to happen, what we want to do, let's put the positive 6 first. To get that 2 to be a 6, we have to multiply by 3. 3 times 2 is 6. And we need a negative 6 for the other equation, because we want these to add up to 0. We want them to cancel out. We need to multiply that by negative 2. Now we need to go through and do what I just said. We need to actually multiply everything across the board, everything that's red by everything that's black. In other words, we're going to multiply this 3 times 2x, and that's going to give us 6x. Just get rid of that for a second. I'll give us 6x. We're going to multiply 3 times 3y, and that's going to give us positive 9y. We're going to multiply 3 times 17, and that's going to give us 51. We want to do the same thing, but with negative 2. The same thing in that second equation. We're going to multiply negative 2 times all of these black terms. Negative 2 times 3x is negative 6x. Negative 2 times 4y is going to be negative 8y. And negative 2 times 24, multiply that. Negative 2 times 24 is going to give us negative 48. All right, give me a little bit more room here at the bottom. And so now we can add these. That was the whole point of doing this, is so that we can add these up. And these will simplify, negative 6 and positive 6x. That's why we wanted to get those two opposite coefficients there. I'm just going to cross them off. If we add up 9y and negative 8y, 9y minus 8y, or 9 minus 8, it's going to be 1y. You don't want to write the 1. Just write the y. And if we add 51 and a negative 48, or 51 minus 48, we're going to get 3. So y is equal to 3, and we're halfway done with our work here. We found y. Now we have to find x. So we're going to go back to the original equations. We could use either one of these equations. I'm going to go ahead and use the first equation. I'm going to use, the second one would work though. I'm going to use this equation right here. And I'm going to write it, but watch how I write the y. I'm just going to write the y in parentheses. So I've got 2x and I still have 3y, but like I said, if I put the y, just for a moment, put the y in parentheses. So I just wrote that that equation that's in the green circle. Now, like I said, we had said a minute ago that y was equal to 3, so I'm going to substitute as the technical word, but I'm going to erase and replace. I'm going to erase the y and replace it with that 3. Okay. Simplify what we have. 3 times 3 is 9, but we still have the 2x. 3 times 3 is 9. And we're going to solve now. We already found y, remember, but we have to find x. Well, what I've done is added 9. We want to do the opposite of that. We want to subtract 9 from both sides. If I subtract 9 from both sides, that's supposed to be a 17. I'm sorry, I forgot my one on there. And let me make that a little bit neater. That's a 17 right there. There we go. Yeah, it's a 17. I just wrote it wrong. So if I subtract 9 from both sides, I'm going to get 2x. 2x is equal to 17 minus 9 is 8. And then I'm going to divide both sides by 2. And 8 divided by 2 is 4. So x is 4. So we have both parts of our solution, both coordinates. Remember, when you write your final answer, it's got to be an ordered pair. The order matters. The x has to come first. So when you write your final answer, let me use red. Put the x value, the 4 first, and then the 3. 4 comma 3 is our solution. Now, I said before, you can always check this. I'm not going to do it right now. But you can check it if you substitute the x and the y into both. That's the important part. You want to check it by substituting into both equations. So let me leave this on the whiteboard, and you guys can go ahead. Now, I want you all to show your work. This is, like I said before, you have to show your work on these. I'm going to stop recording them. And like I said, can you all still see the whiteboard? Oh, darn it. All right, let me, why didn't it, am I still recording?